All right, so for our next talk, we have Deucher and Jammy Zhou. They're going to talk about the AMD GPU driver stack. So go ahead, guys.
Thanks. Yeah, so like Tom said, we're just going to kind of give an overview of our progress with AMD GPU and what the plans are for the next year or so. So a lot of this stuff probably you guys know from last year, but we're basically unifying our closed and open source drivers over a single open source kernel module and sort of a base driver set, which includes the kernel module, a libdrm library, and the DDX. And then, on top of that, we'll be building our existing open source stack, and then as well as our closed source OpenGL stack. We're taking advantage of the existing open source infrastructure. I mean, the AMD GPU is based on Radeon, so it utilizes TTM and DRM infrastructure, DRI protocol, all that good stuff. So this is sort of just an overview of the upcoming things for the OpenStack, the open source base graphics, like I said, which is the kernel driver, libdrm and DDX, the existing Mesa OpenGL stack and our existing Mesa-based multimedia stack, as well as the existing Gallium compute stack, and then as well as we're going to be open sourcing our OpenCL and Vulkan stacks eventually. Whether the timing works out or not to be open initially, I don't think so, but it's definitely going to happen. And then on the pro side, it's sort of a similar story. The main difference is the OpenGL stack. It'll be our existing Workstation OpenGL stack, just ported to work over the open source base graphics stack. Anything you wanted to add?
Yeah, I think for the Pro stack and the Open stack, the major advantage here is we can share the work we have done in upstream side as much as possible, right? For the kernel driver, for the libdrm interfaces, right? For the DDX driver, so the whole stack maybe can be unified in quite a good extent, right? So, yeah.
All right, and then like I mentioned last year, I mean, there may also be some, depending on the feature set for the FirePro stuff, we may have some open source add-ons that might not be upstream, but that would be open source that would be like an add-on to add certain functionality that maybe wouldn't be palatable to an upstream kernel.
Yeah, and for the libdrm interfaces, and we usually consider both the requirements of the open source stack and the closed source OpenGL driver together. So we try to make sure that these interfaces can be shared across both stacks. Yeah.
So this is sort of the stack diagram. This is pretty self-explanatory. The existing Gallium-based stuff, DDX, and then our the OpenCL and Vulkan, which will be open eventually. And then the Pro stack looks pretty much the same, but with the exception of closed source OpenGL.
Yeah, and there's some special part here. You can see some green small blocks right about the FirePro related changes, because we need some workstation specific features, right, for the Pro stack. So okay, so
I mean, it doesn't help with the mic. You just have to speak louder.
okay, that's okay. Yeah, so I mean, because we still need to support some FirePro specific features, right? So probably these changes cannot be merged into upstream kernel, right? So in this case, we probably need to maintain some special patches here, right? So, but that part should also be open source. You can see here the green ones, right?
And it's sort of an overview of what it looks like, the shared kernel module. I don't know. you can read the slide. I've just explained it. So, I mean, why are there still closed source components? I mean, the truth is we have customers today that need certain workstation features, OpenGL, advanced 4.4, 4.3 features that, and OpenGL features that just aren't there yet in the open source stack. So, we need something to be able to support them, but also a solution that allows us to be upstream and to take advantage of all of the benefits that come from that. So where are we now? Today, in kernel 4.2, we merged the initial support for Amdgpu, including support for Carrizo, which is our first Volcanic Islands-based APU, Tunga, which is a Volcanic Islands DGPU, and Iceland, which is one of those Power Express chips with no display hardware on it. And then we did our initial bring up and prototyping support with Sea Islands hardware, which is already supported in Radeon. So that stuff is just, in there. It's not. There's a separate compile option, and at some point we'll probably drop it. But for now, it's there if you want to test it. And we needed a stable base for bring up, so that's what we use Sea Islands for. In kernel 4.3, support for Fiji, which is the R9 Fury-based cards. And the CGS API, which is a new internal cross-component API for different modules, like the graphics module, UVD, VCE, the power management, the display, just an internal driver API. And then KFD, which is the HSA kernel driver for support for Carrizo chips, was added in 4.3 as well. And then our new libdrm library was merged in 2.4.63. Mesa support for Volcanic Islands chips was merged in Mesa 11. And then we have, for a while now, we've actually had our closed source OpenGL and OpenCL support running over the stack, as well as Vulkan.
Yeah, so for the closed source OpenGL part, for example, we added a new EGL support, GBM support, which are required by the Glamour 2D acceleration, right? And this also paves the ground for the potential Wayland and MEA support, right? Because EGL is a must. So with this, it is already there, right? So we added EGL GBM support, and together with the KMS support in the kernel side, so the Wayland and MEA support can be quite easily enabled. So this is for the closed source OpenGL part, right? So, and for OpenCL, we also leverage some new technologies in the latest kernel. For example, for the random node, right? We use the random node to support a console mode OpenCL, right? So we don't require X running, right? We just run OpenCL application in the console mode. So these are already enabled with the new unified stack. And I think this is also, for this part, we leverage the advantages of this unified mass storage, right? So it saved us a lot of resources to enable these new technologies or new libraries, right? And we also did some performance optimization part. So I can say that at this moment, the new Pro stack is comparable to Catalyst now in most cases. So although there is still some other cases we need to improve. So yeah, I think it is in good shape now for the Pro stack. And for the Vulkan, yeah, I think we also have some basic support there based on the DI3 protocol for presentation. So I think, yeah, so it should be in some good shape. So,
all right.
Yeah.
And where are we going? Stuff that's coming up. We had initial support for we have a software-based GPU scheduler. Some of the initial work for it went into 4.3, and it'll probably be finished up for 4.4, as well as improved GPU reset. Integration of the new, we have previously the core open source team did the display support, but now the DAL team, which is our internal display team, is now getting up to speed on open source, and they're going to be contributing directly. So it's going to, the goal is to eventually become, feature comparable to Windows on the display side, and then we're also, working more closely with our internal PowerPlay team for power management. So, our PowerPlay support should also, our power management support will also improve significantly, and of course, continue with new ASIC support.
Yeah, and for the software GPU scheduler part, previously for the initial enablement, maybe some people have tried it. There are some stability issues, but recently we have done some improvement to, especially for the synchronizing part. So we are using the common fence in kernel side now for the implementation, so that we can leverage the existing infrastructure there in kernel side. So I think we are trying to enable it quite soon. So and based on our internal testing, it is really good at this moment.
Yeah, we have our hardware has hardware semaphores that can be used for synchronization between rings.
Yeah.
And previously with the software scheduler, it was slower, but if you just disable the hardware semaphores and do fence weights, its performance is pretty terrible. But we've now gotten to the point where the GPU scheduler is just about, if not as fast as using the hardware semaphores. So
yeah,
it's looking pretty good. And then of course, we'll be open sourcing our OpenCL and Vulkan implementations, and working on interop between the different user mode drivers. OpenCL. So the plan is to open source our existing closed source OpenCL implementation. Because of this, there's a lot of code to review. We were hoping to do an initial open source release, but due to schedules and stuff, it may end up going out as a binary only initially. But the plan is to open source it once we've cleaned it up and made sure it's safe to release. And because it's not really part of an existing project, it will be an AMD project. It's not. I don't know if it wouldn't really fit into Mesa per se, so it would probably be a project that we would maintain. And Vulkan, same kind of story. Once again, we plan to make it open source eventually. It'll also be an AMD maintained project. It's going to be sharing the same code base we use for closed source on other operating systems, but it will be open source eventually. And then another note on the display stuff. Like I mentioned before, we're working closer now with our internal DAL display team is now working directly with us on the driver. So the goal is to eventually be compatible, feature complete across OSs at some point. And the initial support is for DCE 11, which is in Carrizo. And then PowerPlay, we're going to be leveraging a lot of the power components and stuff from the work that our other internal power teams have done, so we can hopefully better deal with a lot of the stability issues and things that we've had with older parts in the code that we had written ourselves. So power management is sort of a black magic, and it'd be nice to have better involvement with our internal power teams.
Yeah, and I think this is also one of the major reasons why there is no deep reclocking or DPM support in our initial AMD GPU driver for Tonga, right? So,
right.
Yeah, so
we've already got it working on Tonga, and we've ported Carrizo to it as well, and we're in. I don't know if we've got it quite working yet, but it's just about there on Fiji as well.
Mm-hmm. Yeah.
Yeah, and just with more and more, we're getting more and more people on board, and look forward to feedback from everyone here and in the community. That's it. Questions? questions?
Why don't you, maybe you can walk around with the mic that way. If you have to answer,
Mhm.
then you'll have the mic.
Okay.
You know what I mean? So
Okay.
why don't you
Okay.
walk
That's
back
okay.
there?
Yeah.
No, I mean,
Oh.
I'm just saying, why don't you walk yourself and take the mic? That way, if you have to answer his question, you.
Okay.
you
Okay. 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 That's good. Yeah. Yeah. Yeah.
Just the cat. Can't talk. The testing bullet on the last slide. Are you looking into? Well, essentially, I'm trying to volunteer someone to port IGT to generic code. Would that be something that might be useful for you to kind of have
I don't know. I haven't looked at IGT.
a kind of as a generic cross-vendor validation platform for KMS drivers?
Perhaps. Yeah.
Yeah, I think definitely, for example, the VBlank related tests would be good to have for us as well. So if you can volunteer somebody to do it, that'd be great.
Okay. Okay. You are. Okay. Okay. Okay.
Do you think there'll be a lot of common code in the Vulkan and OpenCL projects you have that'll be useful for other drivers?
I don't know. We did an internal analysis to see how much code could be shared across vendors, and it didn't seem like there was much that could be. I mean, there's little bits, but it was so little it ended up kind of not. It was like, well, you could, but then I don't know.
So you'd expect, each driver would probably have a.
I think so, but I'm not an expert on Vulkan, but based on other people that were more involved in it, that was.
A lot of the stuff that. Let's hit the mic.
Okay.
A lot of the kinds of stuff that's shared in current OpenGL across drivers in Mesa now, we've just deleted from the API. It's just gone. So all that kind of validate all the parameters and have a complete compiler stack and all that stuff is just gone. So Vulkan is pretty much a hardware abstraction layer. So there's not a lot there in a Vulkan driver that even really could be device independent. The biggest chunk would maybe be the SpearV loader, but if someone makes a SpearV loader as a library that then people could link with, that you would get 90% of the possible benefit from just doing that.
So it would be just a giant library.
Anyone else?
Okay.
Intel hardware similarly has hardware semaphores, and a long time ago I tried to implement a GPU scheduler, and now we have John here who's also done one. And you said it took you a long time to get your software-based scheduler up to snuff with what the hardware can do. Is any of that reusable for other drivers?
Yeah, I think so. We actually purposely kept it outside of our driver, so there's a separate directory and nothing ties into our device structure or anything. So in theory, it could be reused by other.
Yeah, I think the scheduling logic can be mostly reused, and we have some interfaces between the scheduler and the driver side. So if other drivers want to use it, you just need to implement those back-end functions. Yeah.
Here's some documentation.
Oh, good question. Yeah, maybe.
There might be a few comments in the functions.
Yeah.
Thanks.
Yeah. Keith?
I have 3 questions.
Okay.
How well is Glamour working on your hardware with these driver stack? Do you have things that you've submitted a couple of patches to make Glamour work a little bit better? I know Michelle did.
Yep.
Have you other areas where Glamour performance is just not doing what you want?
Certain, Michelle can clarify, but there are certain workloads where things do like a whole bunch of tiny operations of little tiny images that are faster in software.
Okay.
Because I think the vertex overhead is just too
So
high to be.
working on ways to batch operations across X request would help that?
Maybe. I
Okay.
don't know. Michelle, do you?
Maybe, yeah. Okay, well,
One thing Michelle did some work to do to add some sort of basically feature we call shadow primary to do some things in software more easily with
Right.
less
Well, we obviously not doing stuff in software is easier for the hardware in so many ways.
Right.
So if we could fix the
Yeah.
driver to be nicer to the hardware, that would be great. Second question, are you using render nodes under X at all? Do you want to use render nodes in the X world for things like OpenCL or even OpenGL?
Yeah, for OpenGL. OpenCL, definitely.
Yeah. Currently for OpenCL, because OpenCL has no dependency on
Right.
X, right? For OpenGL, I think potentially we can enable it for DI3.
Okay.
Yeah.
Yeah.
I'm just wondering, DRI3 makes this easier
Yeah.
because the person doing the device open is actually the X server
Yeah.
and passes a file. So I'm wondering if that's going to be something you might be interested in contributing code for and figuring out how to make that work. The other question I had was, you're doing a new mode setting infrastructure and involving people that have worked on the mode setting in the closed source group. There's a whole bunch of functionality in the closed source driver. Have you managed to get all of that exposed through the generic KMS APIs, or there's a bunch of magic A and B specific mode setting stuff that's going to be necessary?
I think at this point everything we're exposing fits into the API, but going forward there may be things that I don't know. You guys, anything you've run into?
Maybe there are some software RP for file features.
Right.
Yeah.
That's my concern, is that if there are a bunch of A and B specific functionality, how are we going to expose that in a general way through the Windows systems if we don't have some general abstraction for them?
Right.
You mean from hardware level, hardware functionality?
Hardware through the kernel APIs all the way through the Windows systems to applications. How are you going to do that if there's a semantic mismatch?
Yeah, that's yet
Yeah.
to be solved.
Okay.
Yeah, maybe in this case, we probably needed to contribute to the common KMS stuff, right?
And try to figure out some way to make it not just be an AMD specific thing, but to expose that functionality in a general fashion so that we can actually get applications capable of using it.
Yep.
So, yeah, it's easy to get a kernel driver that does exactly what you need, and really hard to get it so that applications can use it without being AMD applications.
Yep.
And probably the last thing you want to try to do is write an AMD Windows system.
Yeah, okay, thank you.
Anyone else?
Okay, thanks guys.
All right.